So in this question, int val equal to 5 is global variable. Then there is a function which is incrementing value by 10. Then pthread exit 0, int main, PID variable, TID, TID1, TID2, printf, a value percentage %d, comma value. So here a value will be printed as the global variable. If we look this problem from memory point of view, then say this is our original process P1, right? And P1 is this one, the main process, the original process, right? So in original process, value is equal to 5, value is equal to 5 is one variable, and PID is another variable. So when this process is trying to access this value, so this value in this process is 5. So it will print a value equal to 5, right? So initially a value equal to 5 is printed, then PID equal to fork. When PID equal to fork is done, a new process is created with exactly same values which are original process P1 is having, right? And say this process is P2, which is newly created. PID equal to fork. When PID equal to fork, so original process will get PID is equal to PID of the child process, and that is P2, and the child process P2 will get a value of PID equal to 0, right? Because fork returns 0 to the child process and it returns PID of the child to the parent process, right? Then if PID equal to 0, that means we are talking about the child process. So in child process, a thread is created which is calling the function foo, and then immediately it is joined. So child process will not execute further until this thread is terminated, right? And this thread is associated with this function foo. So in this function foo, value is equal to value plus 10, and because this thread is a part of our child process, so a thread, say T1 is created, which is accessing the variables of process P2, global variables of process P2, right? So in thread T1, foo is called, and foo is updating value as value equal to value plus 10. So value equal to value plus 10 is updated in the child process and it becomes 15. The point to note here is that the value of P1 original process is not changed, because the address space of P1 and P2, that is parent and child process, are totally different, and thread is a part of process P2, that is the child process. So it will reflect all the changes in the child process address space, right? Then printf b value equal to percentage d value. So b value is equal to 15, right? And then p thread underscore get, because this statement is executed by the child process, that is p2, and in p2 value is equal to 15, right? Then p thread create tid1 null foo null. Again a new thread is created from the child process and it is associated with the function foo. Fine. So here again foo is called and value is updated as value equal to value plus 10. So again this will update this thread t2 tid1 will be updating the value variable of the child process itself. So now this time this value becomes 15 plus 10, that is 25, and it is joined with the original process. Then printf c value is equal to percentage d value. So this time c value is equal to 25, and else if PID is greater than 0, then that means we are talking about the parent process, that is original process, this parent process. So if we are talking about parent process, that is our P1 wait null, so it will wait its child process to get terminated first, and then pthread underscore create tid2 null foo null, right? So we are again creating a thread in the parent process. So a thread t2 is created here, which is accessing the address space of process P1, right? So a thread T2 is created in the parent process, which is accessing the address space of parent process P1, and it is associated with the function foo, and in function foo value is equal to value plus 10, and for this thread T2 value is equal to 5, so it will update this value as 15, right? And then print f d value is equal to percentage d value.